Hello, everyone, and welcome back to another edition of Indexer Office Hours. Today is the 9th of April, and this is Indexer Office Hours 152. We have a new logo, which is pretty exciting, which many of you can check out in the agenda. This is the town square for ecosystem participants to come together and discuss the most important and relevant topics for indexers. So that's a little rundown about what we do over here if you are new to the call, and we have some new guests, which I'm very excited about. This call will be recorded and posted onto public channels like YouTube. So if you're concerned about privacy, please bear that in mind. But with that being said, it is a conversation. So we do want to hear your participation. So you can get involved in today's conversation via unmuting your mic. And if you're having any challenges, let me know. I can get you sorted on that. Or you can take advantage of the chat box over there, which many people are already using at the moment. So that is it in terms of setting up everything. Now I will head into opening remarks. So as for opening remarks, as always, I give a shout out to the latest GRT IQ episode, and today is no different. We have GRT IQ episode 163 from Zubin Pratap. I hope I'm pronouncing his name correctly. And he's a software engineer and developer relations engineer at Chainlink Labs. So many of you know what Chainlink is, so I don't need to inform you of what Chainlink is. But Zubin has a very interesting journey. He started off his career in law and transitioned his way into building companies and then eventually into tech. He's worked at Google before joining Chainlink Labs. So if you're interested in hearing about his journey and how he got into Web3 and some of the cool stuff that he's working on in the Chainlink ecosystem, definitely go check out that episode right there. And with that, I will hand over to Anna for our regularly scheduled Repo Watch section.
Thank you, Abel, and hello, everyone. Okay, so today on Repo Watch, starting with execution layer clients, we have had 3 new releases since last episode for Firehose Ethereum, starting with the least recent one, so version 2.4.0. This has a lot of changes, but the main one is that a single substream's tier 2 instance can now serve requests from multiple chains or networks. And all network-specific parameters are now passed from tier 1 to tier 2 in the internal process range request. So this allows you to better use your computing resources by pooling all the networks together. Some important mentions here. Since the tier 2 service will now get the network information from the tier 1 request, you must make sure that the file paths and network addresses will be the same for both tiers. So please check the release notes before upgrading. And there have been a bunch of flags, substream state-related flags are now ignored on tier 2. And there's a few more things that you need to be aware, so please do check the release notes. Then the next version on Firehose Ethereum is version 2.4.1, and this fixes thread leak in metering affecting substreams. It reverts a substream scheduler optimization that causes slow restarts when it's close to head, and adds substream tier 2 metrics, Prometheus metrics. And then the most recent version, so 2.4.2, fixes a substream's context leak causing tier 1 responses to slow down progressively. Matthew, would you like to add anything around these versions of Firehose Ethereum?
Yeah, I mean, I can. Yeah, so the new Firehose is changes the architecture quite a bit. I mean, you can still run it the same way as you're used to, but if you're running Firehose on a lot of blockchains at once, as we will as indexers, you know, the number of chains coming to the decentralized network is going to go up, hopefully fast and soon. Which means if you want to process substreams on those different blockchains, then you need, a pile of nodes to process that. So now you can just set it up once, and then you can point your different chains at the same set of worker nodes. So that makes it much, much easier to configure. So especially for people who are on bare metal and not in a Kubernetes cluster. But even with Kubernetes, this is still way more efficient. So so basically you run Firehose Ethereum as your tier 2 substream processing, and then you can pass any of the other substreams from any other chains to the same Firehose Ethereum binary. So yeah, I don't know if anybody has questions on that. Happy to answer. We've been testing it a lot, which is why there's a bunch of Firehose releases. Because just working through some little gotchas. There's still one that's in progress, as I kind of mentioned there in the chat. I was blaming Derek. It's not really Derek, but we're testing one of the substreams, which is not really working right with the latest release. So trying to figure out why it's going slow. So, so the tier 2. So Vince asking a question about the tier 2 for EVM. So if you look at the code base for all of the firehoses, the Ethereum firehose has some extra code in it to handle talking to RPC nodes. So if you want to run a tier 2 node, it has to be the Firehose Ethereum code base, because that's the one that has all the features plus the extra being able to talk to RPCs. So if you want to run Bitcoin Firehose, which is normally run on Firehose Core, Firehose Ethereum is a superset of Firehose Core. So running Firehose Ethereum on your tier 2 node for a Bitcoin tier 1 node is fine. So make sure you run Firehose Ethereum on the tier 2 nodes, regardless of which Firehose you're running on the tier 1 or the rest of the Firehose infrastructure. Hopefully that makes sense. A bit confusing. So when you get to it, just, ping me for questions and I'll walk you through it.
Thank you very much, Matthew. All right. Next up is Arbitrum Nitro, new release. So this is version 2.3.4, release candidate 2. This release improves sequencer reliability and node performance, and it adds metrics for chain pricing data. You can set default flag execution sequencer max revert gas reject to 0 to improve the sequencer reliability. So please check this release out as well. And then moving on to consensus layer clients, we have had a new release of Prism. This is version 5.03, which is a small patch release with some additions and bug fixes. So if you are running version 5.00 or version 5.01, it is recommended that you update to this release. However, if you are running last week's release, so 5.02, upgrading to this is not strictly required. All right. This is all we have on RepoWatch this week, but I would like to take a moment and let you all know that tomorrow we have our next LOH session, and I'm mentioning this because this will be useful for everyone, regardless of whether you're running Launchpad or Kubernetes or not. So this session will focus on high availability in Postgres. So it's designed to discuss the terminology and the operational strategies that need to be addressed to ensure data reliability, recovery, and integrity. We're hoping for an open conversation, but if there isn't much space for that, we will cover stuff like Patroni and how to automate and manage Postgres HA using Patroni, write-ahead log archiving, and how that the role it plays in disaster recovery and database backups and replication, with an exploration of the different types of database servers, so talking about standbys, clones, and replicas to achieve data availability. Again, we will use examples to demonstrate some stuff on Kubernetes for context, but the actual concepts are universally applicable whether you're running Kubernetes, Docker Compose, or traditional bare metal environments. So if this is a topic that's interesting to you, please join us tomorrow at 10 a.m. PST. And with that, I will hand over to Juan. Thank you.
Thanks, Anna. Okay, so getting into Protocol Watch, we don't have a ton to cover today. For forum governance and research, we don't have any new updates since last IOH. For the contract repository, there has been a few updates to some of the open PRs. All of them are experimental and work in progress. This includes changes to Horizon draft changes, staking changes for Horizon, subgraph data service improvements, and subgraph dispute manager improvements. Again, I think all of these are tied to the upgrade to Horizon in the future. But again, they are experimental and work in progress PRs, and I don't think they're gonna be merged anytime soon. But yes, that's pretty much all of the movement that has been noticed in the contract repository. For the network subgraphs, we don't have any new updates regarding releases, but we do have a small heads up that the analytics subgraph for Arbitrum is experiencing some issues. We have been investigating this with the GraphNode team, as this seems to be a case of too many delegators on indexers in Arbitrum, which I guess it's growing pains and case for success, I guess, but it has been causing some issues with the analytics subgraph, particularly because it's not it's a subgraph that does some bad things that we know are bad, but they are needed for some use cases. Some of those bad things are, pre-computing a bunch of data for delegators, and as delegator number grows, particularly for each of the indexers, when there's like tons of delegators, there have been some unforeseen issues, mainly on how, GraphNode handles large amount of entities being loaded and stored. But it's a hotfix has been released, and we are checking on the syncing progress on the resync. So hopefully the availability issues with the subgraph are done relatively soon. That's pretty much it for Protocol Watch. I was gonna hand over to Paka, but he's not here, so I'm gonna hand over to Abel for the open discussion.
That is right. Paka will be joining us next week. Currently, he has a meeting clash, but he'll be with us next week. So that's all we have for those sections. So next, as Juan mentioned, we have the open discussion, and I am excited to reintroduce a guest who has been here before, Justin, and he's going to tell us all about exponential rebates and clear up some confusion that's been currently happening in the ecosystem. So Justin, when you're ready, fire away.
Okay, thank you. Hopefully it won't be too much. I just heard through the grapevine that there was some confusion around exponential rebates. I want to go back and revisit a little bit about the purpose of exponential rebates. The purpose of exponential rebates was to get rid of the gaming that would go on with the Cobb-Douglas rebates. So if you can think back, the amount of rebates that an indexer would receive is not only dependent on their own stake, but also on the stake of other indexers within the network. We felt that this was unnecessary and overly complicated. So the sole purpose of exponential rebates, at least at that point, was to get rid of the gaming. It doesn't get rid of the required to stake for economic security to get back the query rebates. But what it does is it makes the rebates only a function of each indexer's rebates only a function of their individual stake. And the way we set the parameters was basically given the current state of the network and the allocations, pretty much everybody would, no rebates would change from the Cobb-Douglas, and most indexers would get over 95% of their query fees in rebates. So in the original GIP, there was a chart that showed how much of you would need to stake relative to your query fees in order to have that rebate. And I think it's around, if you stake 4 times as much, as your query fees, you're guaranteed over 90%. I think if you stake 7 times as much, you're about over 98%. I can dig up the exact numbers. I want to open the door for questions here, and we could post the numbers, or I could put a comment back in the exponential rebates GIP that has that actual specific relationship. But I want to be here for questions and also other concerns about the exponential rebates and why it may have been causing some confusion.
I see a few people typing and a few people having fun in the comments there. We'll just let people finish typing so they can ask their question. Got a question coming in from Derek. Can you see the chat, Justin?
Yeah, for chains that aren't yet through the CIP, is the effective allocation size reduced to 0 upon allocation closure, or can query fees be claimed as intended? This is something in the exact smart contracts that I actually don't know. I don't know if anybody from our smart contracts team is here, if Tomas or Ariel or Pablo is here, if they could answer that. But that's something that I can try and get back to you on. One thing to note for allocating towards subgraphs without indexing rewards, indexers need to size the allocations respective to expected query fees. Yes, Mark Andrew, is that a question? I think that's a statement, which I agree with. Yep, that makes sense. Okay, so I don't see anybody else typing. The important thing is if these staking requirements, either with or without the indexing rewards, make sense or create undue hardship, please voice that opinion probably in the forum so that we can take it into account when we are trying to make further improvements.
Sweet. Couple people typing. New question from Chris. Can you see that, Justin?
Yes, I do see that. I think right now the allocation optimizer is mostly for indexing rewards. I will have to double check the exact numbers, but I still think that would be the main driver. If instead we change the objective of the allocation optimizer to care a little bit more for query fees and to weight them more relative to indexing rewards for extraneous purposes, we might be able to do something like that. Okay, I think that's it for exponential rebates. Again, if anybody else has any questions or concerns about the required, the trade-off between stake and rebates, feel free to post in the forum or reach back out.
Amazing. Thank you so much, Justin, and also Howard in the comments there, responding to people. And thank you, everyone, for listening and asking your questions. Wonderful. Now we have the next section of the open discussion, which I'm very excited to introduce to you guys. It's all about ChainWatch, and we have the Moonbeam team Moonbeam, there you go, tricky one to say, to tell us all about the project and how you indexers can best index and support the network. So can the Moonbeam team get the show on the road? I believe, Kevin, you're going to be starting, and you also got your colleague Gil, who's going to be supporting as well.
Of course. Thank you so much. We're thrilled to be here. And let me go ahead and just share my screen. And I want to say I'm incredibly impressed with the turnout here. I mean, this is huge. This is awesome. Really impressive that you have such an amazing community here, and it seems like you regularly meet, all the time. So very, very impressed and humbled, and thanks for having us.
Thank you so much.
So just to set out a little bit of the lay of the land here, I'm going to chat a little bit about what Moonbeam is. We'll talk about Moonbeam. We'll talk about Polkadot. We'll talk about some things that we do that are a bit unique. And Jill is going to share some best practices for running Moonbeam nodes. And he has a ton of experience with that for several years. So he's going to be an amazing resource. And so it'll be about 50-50, half and half. And the only other tidbit I just wanted to share is that I live in San Francisco and I go to the Edge and Node House of Web3, having some meetups there sometimes, or just working there or going to meetups. And it's great to be a part of that community as well. So you can see my screen, right? Yep, looks like it's there. Let's start with just a quick introduction to what Moonbeam is. And in order to talk about Moonbeam, we do need to first talk about Polkadot. So Polkadot is a layer 0, which is pretty different, right? You've heard of layer 2s, you've heard of layer 1s, but what's a layer 0? A layer 0 is a base layer that's meant for building other blockchains on top of it. So you're not going to launch a game or a smart contract directly onto Polkadot. Polkadot is meant for you to launch a blockchain. And then on top of the blockchain, then you can launch your game or your smart contract or your dApp. And the philosophy behind Polkadot was quite different than the philosophy that was taken from other chains at the time. Polkadot's been a work in progress since about 2016 or so. And at the time, right, nobody's really thinking about this. And so it was a really unique approach to scaling blockchains and building blockchains that can be interconnected. So the idea behind Polkadot is let chains specialize in what they do best and provide them with the infrastructure and the tools and the interconnective or the connectivity between the chains, right? Provide all of this to them and let them specialize in what they do best. So if you have a chain that specializes in stablecoins, let them do that. If they specialize in smart contracts, let them do that. If they want to do decentralized identity, right? And the way that Polkadot does this is through its relay chain. So the relay chain is the layer 0 chain, and that is the base layer. And on top of it, the parachains or the layer 1 blockchains are built on top of it. So the relay chain has a couple important jobs. It needs to secure all the chains that run on top of it. It also acts as a layer for payments of the DOT token. And so the DOT token is used, you can transfer it around, you can stake it. It's used for a number of different things, but one of them is just paying in order to have a parachain on top of Polkadot. And the third part that I want to mention here is that these parachains that are launched on top of Polkadot are not meant to be independent. They are not meant to be their own island where it's just they do their own thing and they don't talk to anybody. That's possible, but really the value of Polkadot is realized when these parachains are talking to one another. And so XCM is a general message passing standard that allows these different chains to talk to one another. And the way that it works is when you launch a parachain on Polkadot, you're automatically connected to the relay chain by default. And then optionally, you can open up channels to communicate with other parachains. And that allows you to do things like bridging, of course, but it also allows you to do things like use the features that they have, right? Do remote contract calls or utilize products that they have and have exposed to other chains. So if you have a chain that offers a decentralized identity solution or a chain that offers a particular stablecoin, you don't need to, for instance, move over to that other chain. You can perhaps just call a function from the chain that you're on, such as Moonbeam. And so if you're launching a chain on Polkadot, you do have a bunch of benefits and things that make it easier for you to get your blockchain going versus just going out and starting your own layer 1 blockchain by yourself. And one of those things is shared security. So Polkadot is a proof of stake based protocol, and Moonbeam is naturally a proof of stake based protocol as well. And if you're launching a new proof of stake based blockchain, it's very easy to put a price tag on how much it costs to attack your chain. And if you're just getting started, maybe your chain, has a small market cap and maybe not that many tokens floating around. And so that price tag might not be that high to attack your chain if you're just launching an independent chain, outside of Polkadot. But with Polkadot, your chain is secured by the entire stake of the Polkadot network. So not just Moonbeam, but Moonbeam's secured by the entire backing state of Polkadot. And that's several $1 billion. And so that would be the price tag in order to attack Moonbeam. And you get this regardless of the size of your parachain. So if you're just starting off, if you're small, you're launching your own blockchain, you get the full security of Polkadot backing you up. Another thing that you have access to is the Polkadot SDK. And the Polkadot SDK makes it easy for you to add different features to your chain, such as governance, such as staking, such as cross-chain transfers, and all of that. So you don't need to build this stuff. You can just kind of like building blocks, you can pick and choose the features that you'd like and incorporate them into your chain. And again, XCM, I kind of touched on that earlier. XCM is what allows the different parachains to talk to one another. It enables bridging. It enables remote contract calls. And it's something that's opt-in. And when I say opt-in, I mean, if you want to talk to blockchain B, right? If you're blockchain A, blockchain A can go ahead and say, hey, I'd like to open up a channel to B, and B needs to accept it. So it's a double opt-in model. And that's just like a one-time setup thing that you need to set up a channel. Cool. So let's talk about Moonbeam. So Moonbeam launched its mainnet in January of 2022, and we set out to provide complete Ethereum compatibility on Polkadot. So at the time, there was no natively EVM compatible parachain on top of Polkadot. And so you've got lots of DeFi dApps, you've got lots of developers, you've got lots of builders who have launched, let's say, on Ethereum, and they've launched on Binance Smart Chain, but they want to bring their apps over to Polkadot. And there was no easy way for them to do this. So we used a couple different things to provide seamless Ethereum compatibility. And that includes using the tools that Polkadot already has. And that includes building an EVM that's natively compatible with all of your typical EVM smart contracts. And it's not something where it's a compromise or the opcodes are different or there's any sort of different experience. It replicates the EVM on top of Polkadot, and it's built with Substrate. So as a dApp developer, you won't notice any changes. You can deploy to Moonbeam without having to learn any of the intricacies really of Polkadot or anything like that. And of course, this goes for our RPC support. So you'd make the same requests that you would to an Ethereum node. You say ETH get balance, you say ETH get logs, all of that. There's no changes. All of that works exactly as you'd expect. One of the things that was really foundational in the development of Moonbeam is our unified account structure. So Polkadot has a different style of account. It's a different length. It's it's completely different. And so if you wanted to have both an EVM account and a Polkadot account off the shelf, you'd have to maintain two different types of accounts. But we built a unified account system so that you can use your regular Ethereum account that you've got on Ethereum or any other chain. You can use that with Moonbeam, and you don't need to go and set up another Polkadot account. I see we have a couple questions here, so I want to go ahead and answer those, and then we'll keep rolling here. So just so I know, we have until the top of the hour, right, for time management?
That's correct, but if you want, we can go over slightly. There's should
Okay.
be an
All right.
issue.
No, I want to be, I want to be, I think we're right on track. We're perfect here. So Chris is saying, can EVM applications running on top of Moonbeam interoperate with other Polkadot chains via XEM? Yes, absolutely, they can. I'll get a little bit more detail about that, speaking about precompiles and stuff. But the interoperability with other Polkadot chains, that goes through XEM, right? That's a substrate feature. But we expose this functionality to the EVM via our precompiles. So our precompiles allow things like sending funds to other chains and also calling contracts on remote chains. So that is both something that's possible. That's really cool. Yeah, and if you want to take a look, I will. I'll share a link later, but I'll share a link to one of the examples of the bridges that uses XEM to move funds around from Moonbeam to other Polkadot parachains. Vince says, what was the main feature of Polkadot versus Cosmos SDK and ICS that onboarded Moonbeam? Vince, I'm not sure what the ICS abbreviation is. I see. Polkadot versus Cosmos. Sure. Yeah, I think one of the things that was extremely attractive and still is was the Polkadot's model of shared security and the idea that the chains did not have to provide their own security. So I know that Cosmos has since implemented like a similar technology where I think the chains give up a piece of their inflation, or there's a way for them to pay for this ongoing security. But I don't think that was the case, when we were doing research into launching on top of Polkadot. So importantly, we didn't just say like, hey, we're going to launch an EVM and we're going to call it a day and that's that, right? It's very important to have seamless Ethereum compatibility, and that is a huge thing, and it's a big battle. But it can't just be that, right? Because Polkadot has so much to offer. It's got all of this cross-chain functionality. It's got powerful governance features where, I mean, people spend years building, governance protocols on their own chain, and this is something that you just get for free, essentially when you launch on Polkadot, and that's really exciting. So there's a lot of this in place, but we need to find a way for developers to access it, right? If we just say, hey, there's all these crazy powerful features that are available on Polkadot, but oh, by the way, you need to go and learn Rust and figure out how to interact with the Substrate API, that would be a little bit of a harder sell, right? So what we've done instead is we've provided Solidity interfaces, we call them precompiles, and they allow you to access a huge number of these substrate features. So that includes things like governance, staking, and cross-chain transfers via XEM. So these are Solidity interfaces, and all you have to do is enter the address of the precompile and call the function that you need. So if you want to stake, you'll access the staking interface, you'll call the method that you want, which is delegate. You provide the parameters of the collator that you want to stake with, how much you want to stake, the lockup for, not lockup. That's more of a governance term. But you see what I mean, is that dApp developers, they don't need to go out and learn Rust. They don't need to go out and learn how Polkadot works. Instead, they can just call these features through what they're used to working with, which is Solidity. I just mentioned this. With Moonbeam precompiles, you don't have to learn Rust or Substrate. And Polkadot can be, a little bit intimidating if you're coming from another EVM chain. And so we want to make that as easy as possible. Chris is asking, what are Moonbeam's chain parameters, such as block time, EVM, gas per block? Great questions. So Moonbeam's block time is currently 12 seconds. And on our testnet right now, we have a block time of 6 seconds. That's because there's a new feature release called asynchronous backing. And the asynchronous backing feature has dropped the block times from 12 down to 6, and this is something that's going to be rolling out to Moonbeam in a couple of months as well. Gas per block, 15 million gas. The largest transaction can be about 12 million gas. And for the last two questions here, I will leave those for Jill. What is the size of a full node and an archive node? We'll leave that for Jill. What EVM client implementations support Moonbeam? So it's not like the EVM client of like, there are not multiple clients like there are on Ethereum, but there is one, and that would be, you'd run a Moonbeam node. So there's one, canonical implementation. But under the hood, no, so it's derived from a framework that's called, so it uses, the Ethereum compatibility layer is called Frontier, and other Polkadot parachains can use Frontier to help provide this Ethereum compatibility. But the node that you're running is actually, it's a substrate node. And so when you spin up the node, you'll see all of these Polkadot log messages, and you'll see all of that. So running a Moonbeam node is more similar to running another Polkadot parachain node than it is to running a Geth node, for example. And there are a couple more important things that we'll get to. So I'm going to breeze up a little bit here. I think I already talked about this, but I want to touch on Moonbeam collators. So I mentioned Moonbeam is a parachain, and parachain is just a fancy name for a blockchain running on top of Polkadot. So Polkadot has two different essential models for node operators. One is collators, and collators are the block producers for parachains. So Moonbeam's got 76 collators. They're responsible for block production. They are randomly selected as long as they are in the top 76. It's very competitive. People have to have a certain amount of backing stake, and so there's some jockeying going on there to get into the active pool. But they collect transactions, they package them into a block, and then what they do is they pass on the block that they've produced over to the Polkadot relay chain. And the Polkadot relay chain will validate that everything is in good order, and will include that into a Polkadot block so that there's irrefutable proof of what's taken place on the Polkadot parachain. So an important aspect here is that collators need to have both a full node on Moonbeam as well as a relay chain node for Polkadot. And the last thing really that I just wanted to talk about here is that Moonbeam is pretty special in that we have both a substrate API and an Ethereum API. So you can make a request to a Moonbeam node. Again, that's just like one that you'd make to an Ethereum node, ETH estimate gas, ETH get logs, that type of thing. But you can also make a substrate API request. And this would be something that you do through the Polkadot API. There's also a user interface called Polkadot.js apps, and that is kind of like a UI for stepping through the Polkadot API and interacting with it, and it can really help you write your programs because you can see exactly what you need before you kind of write code to interact with the API. So that's kind of where I want to leave it, and I want to hand it over to Jill to talk more about running Moonbeam nodes and best practices, and yeah.
Thanks, Kevin. Can I share my screen? Yeah, I think you're
of course. Yeah, let me stop.
There you go. A nice warm round of applause. Thank you so much. Excited to hear from you, Jill.
Can you see my screen?
Yep, we can see it.
Yeah, perfect. So yeah, hi everyone. My name is Jill. I think Kevin already introduced me, but I'm a DevOps at OpsLayer, and we provide the infrastructure services to the Moonbeam Foundation team. We run RPC infrastructure there for Moonbeam and Moonriver, all their networks. And as part of that, we also run some RPC nodes that are dedicated to graph indexers. My goal here is just to give like a quick look and some tips and requirements and recommendations on setting up a Moonbeam node that should serve as a graph indexer, and also show you where you can find more information if you have any questions or issues while setting up a node of your own. So yeah, I'll be honest, I don't know the level of knowledge of everyone here, so I'll try to keep things simple, and I'll be focusing specifically on setting up a Moonbeam node that you can connect your graph indexer to, not exactly setting up the indexer itself. But we do have documentation on that if you're interested, and that's where I'll start. We have, like, I think the Moonbeam documentation is really good, and that's part due to Kevin's team, and I'll be using it as a base while I explain some things here. Yeah, so in this page here, we are explaining just how to set up a graph indexer, all the steps that are required to set up a simple one, but I'll be focusing specifically on the requirement of having in here, they are talking about the Moonbase Alpha node, which is one of our test networks. We have 3 public networks, Moonbase Alpha for testing. We have Moonriver, which is connected to Kusama on the relay chain. And we have Moonbeam, which is connected to Polkadot on the relay chain. But they are all set up similarly, just the name that changes. But to set up a Moonbeam node for the graph indexer, you specifically need a tracing node. And you might be familiar with the tracing module from Open Ethereum. And what it basically does is it provides a way to query more information about transactions, and that is a requirement of the graph when indexing the blockchain data. So when you're usually setting up a Moonbeam or any substrate nodes, you would have, well, there are a few ways to do it, right? So you can use an image, a container, Docker, whatever, or you can use the binary directly. I'm going to be talking about Docker specifically, or about images in general, just because, well, the information really applies to both, but I think Docker is easier to explain. For Docker, you're going to need a special image called Moonbeam tracing. Usually, if you just want to set up a Moonbeam node, you'll just use the Moonbeam image. But for the graph, you'll need tracing image, like I talked about, because you need this trace module. The special thing about this tracing image is that it provides these files called the WASM override files. And I'm not too familiar, well, I'm assuming not everyone here is familiar with Substrate and how the runtimes work there. And I don't really want to go into too much detail there, but Substrate as a runtime version, for example, Moonbeam right now is in version 28.01, and this is different from the client version. For example, client version is right now is on, for this node, is in 35.0. And when you're setting up a tracing node, you need to make sure that your image can support that override, can support that runtime, sorry. So for example, here on our documentation, we are telling people to install this version, and it actually works. It's not the latest one, but you can see here it says 28.01, and this is the runtime that it supports. And since we are in runtime 28.01, then this image will work. But if this is not always up to date, you can go to our repository in Docker Hub, here. Here. And yeah, as long as you're running any of these images that have 28.01 in the name, it will work. Usually you should use the latest one. In this case, it's 36.1. If all of this is like too confusing or you don't want to really keep track, we also have our Discord, our Moonbeam Discord, which you can access here in the bottom of the documentation. And we have a channel for announcements. I'm not sharing my Discord, but yeah, there's a channel there for announcements, and it will tell you every time there's a new version which tracing image you should use. And this is important because when you're running a tracing node, you need to keep it up to date, or else your graph indexer will stop working. But yeah, so that's like the basics of running a node. You just run the image, and we have the flags that you need here. If you're not familiar with the way running a parachain node works in Substrate, when you're running a parachain node, you are essentially running two nodes. You're running a parachain node and an embedded relay chain node. So for example, if you're running a Moonbeam node, you are also actually running a Polkadot node at the same time. And if you're running a Moonriver node, you're also running a kusama node at the same time. And the way that is configured is you do the initial configuration for the parachain node with the flags. And then you have an empty flag, just two dashes, and then it's the relay chain configuration. Since you're setting up an indexer for like Moonbeam, you don't really care about the Polkadot side, so you can just leave it empty for the most part. One thing that I would recommend, and it's not actually here, but it's in the documentation for running a normal node, is that you can use fast syncing. And this is applying again to the parachain, to the relay chain side, not to the parachain side. It will not work on the parachain side. But this will just speed up the syncing of the relay chain by a lot. Maybe syncing a Moonbeam nodes fully would take about a week, and with this, it might just take a couple of days. Another thing that I would like to point is this, and there was a question related to this. This flag here, you need an archive node to keep the information of all the blocks. If you want to index the blockchain from Genesis, from block 0, you obviously need information about all the blocks. So you need to keep this flag here to disable pruning. Otherwise, the pruning default is 256, so you would keep 256 blocks worth of data in your nodes, and well, that wouldn't work if you want to index from Genesis. What this means, the downside of this is that it's an archive node, and right now the disk space for a Moonbeam node, for the parachain side, for Moonbeam, it will be about 1.2 terabytes. And the Polkadot side, if you're using pruning, it should take only about 40 gigabytes. So you should need about 1.5 terabytes if you want to keep a bit of space. And for Moonriver, it is about 1 terabyte. Yeah, and since I'm talking about requirements in terms of memory, I will recommend about 16 gigabytes memory to run a Substrate node. You might be able to get away with 8 gigabytes, but Substrate nodes tend to take a lot of memory while syncing. So if you see your node start dying out of memory because of that, then you'll know you need more memory. One more thing I wanted to talk about. These flags here are the ones specific to the tracing node. They are required in the tracing node, but not in a normal node. So if you are used to running a normal Moonbeam node or any normal Substrate node, you don't need this, but these are required for the tracing node. So if you're running a graph indexer, you'll need this. And we have an explanation of what all the flags do in this documentation. By the way, let me link all the documentation on the Discord so people can follow along. One more thing I want to talk about is where you can get information. Obviously, this documentation is very good, and you should be able to follow it and not have any issues. But if you do have any issues, like I mentioned, we have the Moonbeam Discord here, and it has a node runners channel, and you can pop up there anytime and ask any questions. I'm always there. You can also obviously feel free to message me directly. And yes, we don't have a lot of time, so if there's any questions.
Yes, we have quite a few, so let me roll up to where the last question was answered. I believe there was a question on storage from Vince. So Vince, do you want to share some more context on the question you have? Apologies if I've missed that reference,
Oh,
but yeah.
I think he answered me with the 1.5 terabytes. And then I guess I have the same question as Chris is what's like the growth rate of the chain currently?
Yeah, that is a good question, which I don't have the answer with me right now. I could check. Do you happen to know, Kevin? Probably not.
I don't know the exact at this time.
I can look it up while other people do questions if there is one.
Got another question from Chris asking, does Moonbeam intend to add EAP 4844 blob transaction support?
That has to do with like sharding, right? Proto-dank sharding.
Yes, if I'm not mistaken.
Okay. I haven't seen anything about it specifically recently, but our goal is always to keep, parallel with Ethereum and parallel with Polkadot. So if that's something that's that comes to Ethereum, then that's probably something that we would eventually try to support.
Awesome. Sorry. Any more questions? I see a few people typing. Well, that's a good question. What's the most exciting app on the Moonbeam?
I'm a DeFi person. Oh, you're good. Yeah, I'm a DeFi person. So 𝗨𝘀𝗶 is probably one of the favorite applications. Also Moonwell, as well as a lending and borrowing application. And I want to give the 𝗨𝘀𝗶 people a shout out because 𝗨𝘀𝗶 lists new assets that are connected via XCM, right? So there's a parachain called Manta. Manta launched a token in like January or something, and 𝗨𝘀𝗶 acted right away in order to add support for moving the asset over from other Polkadot parachains where it launched, and then being able to trade it and put it in pools and everything on Moonbeam. So real showcase of the interoperability of Moonbeam and Polkadot, and the fast executing team. I was really proud to see that. In terms of, we do have a comprehensive list of all the dApps on Moonbeam, or all the ones that we are aware of, and that is on apps.moonbeam.network/app directory. So I'll leave that link here. Yeah, we are big on gaming and NFTs too. So gaming, there's games like Exiled Racers is one. Animo is a first-person shooter game. Steak Machine asks, can we use any asset from Asset Hub on the Moonbeam network? Any asset that is listed on the any asset that's listed on the Moonbeam dApp. So there should be, let me show you here. So if you go to this cross-chain here, this parachain bridges feature, you can use anything here, but it's also possible that other bridges might list a token for their bridge before this application does. So this isn't the only place to bridge from Asset Hub. There are other places as well. Jonathan says, any docs about building or downloading a tracing node binary instead of using Docker? Yeah, absolutely. So you can follow. Yeah, sorry, Joe.
Okay, go ahead. No, go ahead. Sorry.
No, you got it.
Yeah, it's in the same page that I linked. above. We have basically instructions on how to use both Docker and the binary. Basically, you just need to download those special WASM override files that I mentioned and put them in like the directory that you mentioned. It's very simple.
Awesome. Gilles just posted the link there. Any more questions? See, Chris is typing. And Billy as well. So the question from Chris is, when will the Moonbeam CIP chain integration hit the forum?
Good question. I don't know the exact date, but you'll be able to see it here. And then the other one that I want to show you is Moonbeam poke assembly. So the forum is like the place where long form discussions are posted, and then the actual voting would take place here on poke assembly.
Gotcha. I've heard of some rough dates, but I also need to confirm.
For sure.
Yeah. Awesome. Billy and Chris are also typing some more.
Oh, we're excited to be here too. Thanks, Chris.
Amazing. Amazing. It's a pleasure to have you guys. Okay. Oh, Billy's still typing. Alrighty, yeah, she's mentioning the POAP. Okay, yeah, let's first of all, before we go into POAP stuff, say a big thank you to Kevin and Gil for going through all of that. We very much appreciate you guys taking the time to break everything down, the slides, and answer all the questions, share the links. I learned a lot, and I'm looking forward to how things progress with Moonbeam in the graph ecosystem. Any final words from either of you before we wrap that section?
Just thanks so much for being here. And you saw our doc site here. That's got a lot of different tutorials. And then our Discord is discord.gg/moonbeam. So I'll share that link here as well.
Yeah, thanks everyone.
There you go. Another warm round of applause. Thank you both for sharing all the amazing information. Okay, well, now I want to turn the attention to the POAP. And can I get my trusted sound effects folks to celebrate this wonderful day where we honor our good friend and loyal IOH participant and community member, Juan.
Juan!
with a magic secret word. So if you want to get your POAP, I posted it. There you go. Pilly's reposted with the instructions to access the POAP. So we hope you guys enjoy that POAP there, and we hope you enjoyed the entire episode, the entire call. As I said, I found it very informative, and I'm very grateful for each and every one of you who are here, and hopefully you found it interesting, entertaining. And we look forward to seeing you all again, same time, 6 p.m. UTC next week. Thank you all, and goodbye. Take care.
Very nice.